Okay, Module 16 Study Guide. Let's get started. So write an exponential function to model each situation. As always, please try to answer all of these questions on your own before watching the study guide and before looking up the answers. But feel free to use this if you get stuck on a particular problem. Just don't use it for every single problem on here. That way you are 100% confident that you're ready for your test tomorrow. These first few problems are all about exponential growth and exponential decay. So the growth formula, let me erase that. Growth formula, you need to know this for your test, is going to be y equals a times 1 plus r raised to the t power, where a is going to be your initial value or initial amount, r is going to be your, if it's a growth, it's going to be your growth rate, and t is going to be your time. Whereas the decay formula would be y equals a times 1 minus r raised to the t power, where a is your initial value, r is your decay rate, and t would be your time once again. So make sure you know these two formulas for tomorrow's test. Very important. So number one, when solving these type of problems, you want to look for those keywords that tell you whether there's going to be a growth or a decay. The directions state to write an exponential function to model each situation, then find the value of the function after the given amount of time. Number one says the starting salary of a construction company is fixed at $55,000 and increases. It's a word right here that tells us this is going to be an annual, it is going to be an exponential growth. It increases at a rate of 1.8% for 4 years. All right, so A would be your initial value, and in this case, A is going to be 55,000. That is the starting salary of a construction worker, or of a construction company, okay? And then your rate, your growth rate, well, it's 1.8%, but remember, you want to change that to a decimal, so just scoot the decimal point over 2 points to the left, and that would give you let me change this back to black, 0.018 would be your growth rate. And then last but not least, your time. Time is going to be 4 in this case. You write your formula, it would be y equals 55,000 times 1 plus 0.018, all raised to the 4th power. Then you would just need to plug this into your calculator. And if you plug this into your calculator, you would get your answer, which would be y equals, and we're going to round it to the hundredths place value, so it would be $59,068.21 after 4 years. That's how much this construction company would pay its employees. Next, the value of a piece of fine jewelry is $280 and decreases at a rate of 3% yearly for 7 years. So your initial value is going to be $280, and then your rate of decay in this case would be 3% as a decimal would be 0.03, and your time is going to be 7 years. Now this is a decay. This is an exponential decay, so therefore we would use the formula that would have 1 minus r instead of 1 plus r. So this would be y equals your starting value, which is 280, times 1 minus your rate of decay, all raised to the 7th power. Then you just need to put all of that into your calculator. And if you do, you get $226. And again, because we're dealing with money, we're going to round it to the hundredths place value. So it'd be in 24 cents. That would be your answer. That's it. Next, the rent for an apartment was $6,600 per year in 2012. if the rent increased at a rate of 4% each year thereafter, use an exponential equation to find the rent of the apartment in 2017. So we have 6,600. It's increased 4%. Now what would your time be? Well, we're going from 2012 to 2017, so that would be 5 years, right? So your time is going to be 5 years. What's your initial value? Your initial value is 6,600. Your rate of growth is going to be 4%, so that'll be 0.04. And your time is going to be 5 years, because between 2012 and 2017, there are a total of 5 years. Now, this is going to be an exponential growth, and I know that because of this keyword right here, increase, rent increased. So it's going to be y equals 6,600 times 1 plus your rate of growth, which is 0.04, all raised to the 5th power. And if you do that and put all that in your calculator, you would get your answer, which is your new rent was going to be $8,029. And again, because we're dealing with money, we round it to the hundredths place value, which would be 91 cents. That would be your new rent amount after 4 years. After 5 years, I'm sorry. After 5 years. And then last problem that deals with exponential growth and exponential decay. Population of the town was 14,000 in 2010. The population decreased at a rate of 1.5% each year thereafter. Use an exponential function to find the population after 10 years. Okay, so our initial value is going to be 14,000. Our rate of decay is going to be 0.015, and our time is going to be 10 years. This is going to be an exponential decay, and we know that because this right here says decreased, right? So this is going to be y equals your starting point, 14,000, your initial value, times 1 minus 0.015, all raised to the 10th power. And if you put all of this into your calculator, you will get your answer, which is y equals $12,036.23 if you round it to the hundredths place value. I'm sorry, this has to do with population, so normally you'd round this to the nearest whole number, since it does deal with population, so that would be 12,036. Okay, so I'm using a table. So remember, the exponential form of an exponential equation is y equals a times b raised to the x power, where a is your y-intercept, b is your multiplier. Okay, so if we look at this one, it's 5x. What number's in the a position? Well, that would be a 1. There's an invisible 1 there in the a position. What's our multiplier? What does b equal? B equals 5. And in order to solve this using a table, we would just need to do what we did last week. Create a table, x, y, put your y-intercept in there, which would be 0, 1. And we would need to keep finding values until we get to 625 by using our multiplier. So if we use our multiplier is 5, so 1 times 5 is 5. 5 times 5 is 25. 25 times 5 is 125. 125 times 5 is 625. So when are we going to have 625 as an answer? When x is 4. Same with this next problem. A is going to equal 2/5. B is going to be 10, which is your multiplier. Alright, so create your table. And we'll put our y-intercept up here, and then we're multiplying by 10 every time. So I don't think we'll have to go too far for this one, but 2/5 times 10 is 4, and then 4 times 10 is 40. So we could actually stop right there. So when will our answer be 40? It would be at x equals 2. All right, you could change this if this confuses you to 1/16 times 6 to the x power equals 81, and then it's a little easier to figure out your A, B's, your A and your B. Your A, your initial value is going to be 1/16, your y-intercept is going to be 1/16, and your multiplier is going to be 6. And you create a table until you get to 81, so x and y. I'll put my y-intercept at the top, which is 0, 1/16. And then we start multiplying. Our multiplier is 6. So 1/16 times 6 would be 6/16, which would simplify to 3/8. Then 3/8 times 6 would be 18, which would be simplified to 9/4. Then 9/4 times 6 would simplify to 27 halves, and then 27 halves times 6 would be 81. That would be 81. That would be your value. So your answer here is going to be x equals 4. That's when our answer would be 81, and that's how we would solve this using a table. And the last type of problem, here's where you would need your graphing calculator. So it says a town with a population of 600 is expected to grow at an annual rate of 5%. Write an equation and find the number of years it is expected to take the town to reach a population of 900. So first we'll have to write an exponential equation, and it's growing at an annual rate, so it's going to be an exponential growth equation. So that's y equals a times 1 plus r raised to the t power. Well, what is a in this position? What is our initial value? Well, the initial value is 600. That's the population. Now, the multiplier, I'm sorry, not the multiplier, the rate, the growth rate is 5%, which would be 0.05. And we don't know the time yet. We're trying to figure out the time or how many years it would be for the population to be 900, right? So first let's write our equation. That's going to be y equals 600 times 1 plus 0.05 raised to the t power. Let's simplify this a bit. This is going to be y equals 600 times 1.05 raised to the t power. Okay, and we know y is going to be 900. 900 equals 600 times 1.05 raised to the t power. So get your crowd calculators, go to y equals, and then for y1 you're going to put 600 times 1.05 raised to the x power. Then for y2, just like we did in class, you're going to put your answer value, which is 900. Okay, hopefully you have your calculator in your hand right now and you're doing that where it says y1. I'm sorry, where it says y equals. y1 you should have 600 times 1.05 raised to the x power, and then y2 you should have 900. Okay, then you would click on graph, and once your calculator finishes graphing the exponential function, you would go ahead and click on calc, which you would get to by clicking second and trace, and scroll down to where it says intersect and press enter 3 times. And if you do that, you would get y equals 8.31, and I'll just round it to the hundredths place value, 8.31. So a little over 8 years for the population to be at 900. That would be your answer. I'm sorry, I put y equals, and that's not what y equals That's what t equals, so that's very important. T is going to equal 8.31. That's how much time it's going to take. We already knew what y equaled. Y equaled 900. So 8.311 rounded to the hundredths place value would be t, which means it will take a little over 8 years for the population to reach 900. All right, that's it. 8 problems. Only 8 problems for your study guide today. 15 minutes. That's what your test is going to be on tomorrow. Make sure you study, and I will see you tomorrow. Have a great day.